So welcome back. So then here's the statement that I need you to memorize from the last video, and this will help us to make our statements that we're supposed to write. After we do all the math, we're writing our statements of what those confidence intervals mean accurately. So here's an example. A May 2000 Gallup poll found that 38% of a random sample of 1,012 adults said that they believe in ghosts. So find a 95% confidence interval for the true proportion of adults who believe in ghosts. So state the parameter. What is P? P is equal to the true proportion of adults who believe in ghosts. Next, justify the confidence interval needed. And again, we need to take a look at our assumptions. The sample must be random, which is stated in the problem. And 2, the sample should be large enough. And again, we have to look at our NP. N in this case is 1012, and P, as it said, was 38%. So you multiply those together, and you get 384, which is definitely greater than 10. And then N times Q, so again, 1012 times 0.62, and a 62 is again the complement of the 38. That's where that comes from. And that again is way bigger than 10. So the sample is definitely large enough. And hopefully it's not too large. The sample should be less than 10% of the population. The population should be at least 10,120 adults, which we'll need to assume. So again, there's that difficulty. We'll have to definitely assume that that is true. And since the conditions are satisfied, a confidence interval for proportions is appropriate. So now we go to the calculation part. We're going to calculate the confidence interval. So what does that look like? We know that there's 38%, and we have the number of samples, or number of people, in this case it was people, who believe in ghosts, and the number of people who were sampled, I should say. And we have a 95% confidence interval that we're checking. So again, N is not the percent who believe in ghosts, it's the number that were sampled. And this is the percent of people who agreed. So then what does that look like? So we're using our confidence interval formula that was stated in our second video. So now we have 0.38 plus or minus, and since our confidence interval is 95%, we're using the critical value for the 95%, which is 1.96, and that's multiplied by PQ divided by N. And then that gives us, again, because of the plus or minus, this is a number 30.38 plus some number, that gives us the 41, and then 0.38 minus that number, which gave us the 35. So please be careful on here. This is creating an interval that we are 95% sure or confident that P is going to fall between. So explain the interval in the context of the problem. We are 95% confident. Again, use your recipe. We are 95% confident that the true proportion of adults who believe in ghosts, there's that context that I was underlined in green. So we are 95% confident that the true proportion of adults who believe in ghosts is between 35% and 41%. So there's those two blanks that I was telling you about in the recipe. So what happens if we want to be 99% confident now? So if we wanted a 99% confidence interval for the previous problem, what would we change? So look back. What would we change for the 99%? Hopefully you understand that the only thing that's really going to change in the problem is Z star, is our is our critical value when we're multiplying out. So our 99% is our critical, or our confidence interval. So therefore, when we get to our critical value, we use the 2.576 number for our critical value that corresponds with the 99% confidence interval. So again, here's our data. And our answers really don't change much. But let's compare them. So again, here's this number here, and we're adding and subtracting this value. You're comparing the previous value, that's 35 and 41, so 0.35, 35% and 41%, versus 34% and 42%. What happened? The interval is larger. The 34 and 42 is wider on a number line. So only the margin of error is changed. So the interval is larger. When we went to a higher or larger confidence interval, the interval is larger. Hopefully that makes sense to you. So let's take a look at another example. Another Gallup poll is taken in order to measure the proportion of adults who approve of attempts to clone humans. What sample size is necessary to be within plus or minus 4% of the true proportion of adults who approve of attempts to clone humans with a 95% confidence interval? So we want to use a 95% confidence interval, and we're given 4%. And notice there's no number of sample size. We don't know what the sample size is. And we know the plus or minus. We know the confidence interval. So, to find the sample size, remember that margin of error that I talked about earlier in one of the videos? Here's the formula we're looking at. So since we have not yet taken a sample, we do not know a p-hat. So this formula is the one we'll use. So what p-hat do you use when trying to find a sample size of a given margin of error? Do you use, I don't know, like 10%? 90%? Well, that would be like really close. Then one's, look how far apart they are. We want to use like the worst case scenario. And this one is like, one is really good and one's really bad. So that wouldn't work. That's a little better. We want to use the worst case scenario. Ah, there it is. 50-50 is as bad as you can get. So by using 0.5 for p-hat, we are using the worst case scenario and using the largest standard deviation in our calculations. So let's take a look at what that looks like in this context. So we use the margin of error with z star, our critical value, as 95%, which is that 1.96. P is 50%, Q is 50%, and notice here again we're solving for N. So our time is running out. I'm going to have to pause here and we'll come back to it in the last video.